All right, here we are on lesson 15.2, our second trig, check on learning. So let's just jump right in. So it says y is a 30, negative 60, negative 90. I'm sorry, that's just 30, 60, 90 triangle inscribed in a unit circle in two different orientations in the figure below. The triangle is inscribed in two different orientations, so the angle of rotation is 30 degrees, and the other is 60. So that's all they're showing, is that one has 30 degrees right there, the other one has 60. Check our answers. Too easy. So consider the point of intersection xy of a unit circle and the terminal side of any given angle theta. Explain how the signs of the basic trigonometric functions in all four quadrants are justified by signed values of the coordinates of these points. So I'm just going to draw a picture real quick just to remind myself, because that kind of helps me. So the coordinates of any point quadrant 1 just in case you forgot, quadrant 1 have signs plus and plus. And quadrant 2 have signs negative x, positive y. Quadrant 3 has signs negative x, negative y. And then quadrant 4 has a positive x and a negative y. Check our answer. Positive, positive, negative, positive, negative, negative, positive, negative. Which is what we have. Ooh, do I actually get to do some work? The point 8, negative 15, I threw all that, is on the terminal side of an angle of rotation theta from the x-axis. What are the values of the three basic trigonometric functions of the angle theta? Enter the correct values in the box. Enter exact values, do not round. Anytime they say enter exact values, that probably means that they want like either the pi or a fraction or something like that. So just so you're aware of that. So let's draw a picture. 8, negative 15. So 8, negative 15. 8, negative 15. Angle rotation theta from the x-axis. What is the values of the sign? So what do we know? We know our x value is 8. We know our y value is negative 15. And we could figure out the hypotenuse, which we're probably going to need. So how are we going to figure out the hypotenuse? That's right. We're going to use the Pythagorean theorem. Now we need to square root all that too. So I totally know all of those values off the top of my head. So just to make everybody feel better, I'm going to stick them in the calculator anyway. I'm kidding, I don't know any of those. Plus, so you'll notice I'm just dropping the negative sign because when it's squared, it doesn't matter. So I'm going to find the square root of our answer, and that is 17. So our sine, because this is our theta, is, let's see here, negative 15 opposite over adjacent. So we got fraction, negative 15 over 17. Cosine is adjacent, which is 8 over hypotenuse. And then tangent is opposite over adjacent. So that's negative 15 over 8. Which is exactly what they got. See, and you guys thought trig was going to be hard, didn't you? I'm sure it'll get worse. So a building casts a 24-meter long shadow when the sun is at angle 75 degrees relative to the horizon. How tall is the building? Round to the nearest whole number and to the correct value in the box. So, you know what we're going to do? Draw a picture. This is going to be stick figures to the best. So we have a building. You guys like my building? It is 24 meters long and casts a oh, no, I'm sorry. Back up. We have a building that then casts a shadow that is 24 meters long when the sun is at 75 degrees above the horizon. So that means, what I think that means is that our theta here is going to be 75 degrees. So then from that, we can figure everything else out. What are we trying to find? How tall is the building? So x is, I shouldn't say x. We'll say b for building. So we need to find b. We have the angle, we have the adjacent, and then we have the, we're looking for the opposite. So we need a sine, or a trig function that has opposite and adjacent. Which one is that going to be? If you said tangent, you are correct. So we're going to find tangent of 75 degrees, and that is equal to opposite over adjacent. So we're going to do some algebra. We're going to multiply both sides by 24. Equals the height of the building. And I'm sure you watched me in my video as I ensured that my calculator was in degrees. Where's my calculator? There you are. So I can do that again. I hit mode, radian degrees, done. It also tells me up here, degree. So that might be a thing that you should check on your calculator. Make sure it's the right thing. So we got 24 times tangent of 75 degrees equals 89.569. Where are we rounding it to? Nearest 10? Oh, the nearest whole number. So technically that would be rounded to 90 meters tall. Which is what they got. 90 meters tall. So again, I've said this before, but believe it or not, this trig stuff is actually probably one of the more useful things, or at least easier for me to answer the question of, when am I ever going to use this? So the trig functions that we learned and we're practicing are very handy both in your mathematic career, your scientific career, and who knows, maybe in real life. So either way, I will see you in class.